Optimization and simulation, these are powerful techniques in business analytics. They help organizations make better decisions. They make businesses make better decisions, modeling real-world scenarios and finding the most efficient solutions. So, in this lecture, we're going to cover how businesses use optimization to maximize performance and minimize cost, while simulation techniques help analyze complex systems under uncertainty. So this lecture, we're going to explore model-based decision-making, okay? And again, it's going to be all about improving decision-making efficiency. We're going to discuss different categories of models. We're going to discuss how to perform optimization using spreadsheets and how decision tables can simplify complex choices. And finally, we're going to dive into simulation methodologies, examining how businesses use simulations to analyze uncertainty and improve strategic planning. So prescriptive analytics goes beyond simply describing past trends or predicting future outcomes. It provides actionable recommendations. And it does this to help businesses make the best possible decisions. It leverages techniques like optimization, simulation, and decision modeling to evaluate multiple scenarios and determine the most effective course of action. So a great real-world example is airline pricing optimization. Airlines like Delta and American Airlines use prescriptive analytics to adjust ticket prices in real time, based on things like demand, weather conditions, competitor pricing, customer booking behavior, and they do this by running simulations and applying optimization models. With this, they can maximize revenue and make sure that seats are filled efficiently. So the value of prescriptive analytics, it lies in its ability to enhance decision-making, reduce risk, and improve operational efficiency, helping businesses across industries make more informed and profitable choices. Model-based decision-making uses prescriptive analytics to move beyond simply understanding past trends, which is descriptive analytics, and predicting future outcomes, which is predictive analytics. What it does is it actively helps businesses determine the best possible course of action. And it does this by leveraging analytical models, optimization techniques, simulations. By leveraging these things, companies can evaluate different choices and make data-driven decisions. And these data-driven decisions should be helpful in terms of maximizing efficiency and profitability. For example, if there's a retail company, it might want to maximize profit by determining the optimal amount to spend on promotions and product pricing. Prescriptive analytics can analyze historical sales data, can predict customer demand. It can then use optimization models to recommend the most cost-effective marketing strategies that drive sales while keeping expenses low. In the real world, companies like Amazon and Walmart, they use prescriptive analytics to optimize supply chain management. So you can decide how much inventory to stock, where to place distribution centers, and the best routes for delivery trucks. In finance, banks apply prescriptive analytics to detect fraud in real time, to recommend whether a transaction should be approved or blocked. Think about healthcare. Hospitals use prescriptive models to schedule staff, to allocate resources, and improve patient care. So the business value of prescriptive analytics lies in its ability to reduce costs, increase revenue, improve efficiency, and minimize risk. And that's why this is a game changer for data-driven decision-making across, essentially all industries. So businesses rely on different types of decision models to analyze complex problems and evaluate alternatives and make informed decisions. Optimization models, they're going to help you find the best solution, whether it's finding the best inventory level. Sometimes they use formulas or they allocate resources efficiently through algorithms like linear programming. Simulation models allow businesses to test different scenarios before making costly decisions. We've talked about several of the ways that this can happen, but these are the different categories. Optimizations with few alternatives. Okay, you can think of a decision tree. Optimization via an algorithm. This is where the linear models will work here. Optimization with an analytic formula. Okay, inventory models. A lot of this is going to be done in Excel. Anyway, heuristics, predictive models, etc. Math models for decision support provide a structured way to analyze complex problems by linking decision variables, uncontrollable variables, and result variables. Decision variables, these are factors businesses can control, such as pricing strategy, marketing budgets, or production levels. Uncontrollable variables represent external factors like economic conditions, competitor actions, or customer preferences. And these can impact the outcome, but they cannot be directly influenced. These variables interact through mathematical relationships. Okay? Sometimes it involves intermediate variables. Okay? But they all should produce a result variable, which is the final outcome that businesses seek to optimize, such as profit, cost reduction, or market share. So a real-world example is supply chain optimization, where companies adjust inventory levels, decision variables, while accounting for demand fluctuations and shipping delays, right? The uncontrollable variable, to achieve the best delivery performance and cost efficiency, the result variable. So by using quantitative models, businesses can make data-driven decisions, reduce uncertainty, and optimize performance in various industries, from finance and healthcare to logistics and retail. So decision models are essential for helping businesses analyze trade-offs, predict outcomes, optimize strategies across different industries. And every model is going to consist of decision variables, right? The things that we said, factors that businesses can control. Result variables, right, which is the outcome that we're looking for. Uncontrollable variables, you have to identify these external factors that impact the outcome, but they cannot be managed directly. For example, in financial investment, companies can choose how much to invest. How much you invest, that's a decision variable. If you want to maximize profit and your return on investment, that's your result variable. While you're dealing with inflation, interest rate, and competition, those are all uncontrollable variables. In marketing, businesses decide where and how much to advertise to increase market share. But customers have a certain income level. Competitor actions, things like that. These all remain outside of their control. These are uncontrollable variables. So these models are valuable because they allow organizations to simulate different scenarios, reduce risk, and make data-driven decisions, ultimately leading to more efficient operations, cost savings, and competitive advantages in the respective industries. So math models are essential for decision making because they use equations and inequalities to describe relationships between key business variables. One simple example is the profit equation, P equals R minus C, where P, profit, is determined by the revenue minus the cost. Businesses use this fundamental model to analyze financial performance and make pricing or cost-cutting decisions. Another example is the present value formula. Okay, this present value formula right here. And it determines the current worth of a future cash flow. And this helps companies evaluate investment opportunities. So say the formula P equals F over 1 plus I, all raised to the n power. What this does is it discounts future earnings by an interest rate, I, over a number of years, N. For instance, an investment promising $100,000 in 5 years at a 15% interest rate, it means that it has a present value of $62,092 today, meaning an investor would only pay that amount to achieve a future return of $100,000. And these models are widely used in finance, operations, and strategic planning, allowing businesses to quantify risk, forecast financial outcomes, and optimize decision-making for long-term success. So spreadsheets are the most widely used tool for decision modeling. Spreadsheets give you flexibility, ease of use. They have powerful built-in functions for data analysis and optimization. They enable businesses to perform what-if analysis, goal-seeking, scenario modeling. They're essential for financial planning, budgeting, and forecasting. So they have features like macros and add-ins, stuff like that. So spreadsheets can automate repetitive tasks and integrate complex decision models seamlessly. So for instance, a company can use the Microsoft Excel Solver tool to optimize resource allocation, or it can use Google Sheets for real-time collaboration on financial models. So whether this is used for static reports or dynamic simulations, spreadsheets remains a critical tool in business intelligence and strategic decision making. So this Excel-based static model here, it's just calculating monthly loan payments using the payment function, the PMT function that you see right there. And it's just considering the loan amount, the interest rate, and the number of payments by breaking down the annual interest rate into a monthly interest rate, and then converting those loans years into months. And this is going to help businesses and individuals quickly analyze loan affordability and repayment plans. So this dynamic Excel loan model, it builds on the static version by incorporating prepayments. In this case, that's what you see over here. This is going to allow the user to see how making a couple extra payments impacts the loan's payoff times and interest savings. Just by adding a $100 prepayment per month, the model shows that the loan is paid off in 270 months instead of 360, reducing total interest costs. Now this type of dynamic modeling, it's valuable for financial planning, mortgage analysis, and business loan management. And this lets users make informed decisions about debt repayment strategies. There's also optimization through mathematical programming, which focuses on finding the best possible solution to a problem by efficiently allocating scarce resources. And it does not just scarce resources, but scarce resources amongst competing activities. So one of the most widely used techniques is linear programming. And linear programming helps businesses maximize profit or minimize cost while adhering to constraints like budget limits, labor availability, or production capacity. So for example, a manufacturer can use linear programming to determine the optimal mix of products to produce, balancing raw material costs and production constraints to achieve the highest profits. Mathematical programming is essential in logistics, finance, and supply chain management, enabling businesses to make data-driven, efficient, and cost-effective decisions. So linear programming follows a structured approach to finding the optimal solution for decision-making problems involving limited resources and constraints. So the first step is to identify key components, including decision variables, what we control, the objective function, what we want to maximize or minimize, such as profit or cost, and the constraints, which are limitations like capacity or demand. Next, the model is represented using specialized tools, such as Lindo for advanced optimizations or Excel Solver for spreadsheet-based linear programming models. And then finally, the model is going to be run and analyzed, letting the business determine the best possible solution for problems like production planning, logistics optimization, workforce scheduling, or just making sure that you're efficiently allocating your resources and reducing costs. So this linear programming example right here focuses on product mix optimization. Okay? It's trying to determine how many units of two mainframe computer models, CC7 and CC8, should be produced to maximize monthly profits while considering labor, material, and marketing constraints. So the decision variable is the number of CC7 and CC8 units to manufacture. How many units? Constraints include available labor, 200,000 days per month, materials budget, 8 million per month, and minimum maximum production limits. Each CC7 mainframe contributes $8,000 profit, while each CC8 mainframe contributes $12,000 in profit. So we have an objective function which seeks to maximize the total profit, ensuring optimal allocation of resources. So this type of linear programming model, it's commonly used in manufacturing, in supply chain management, and production planning, helping businesses make data-driven decisions to increase efficiency and profitability. So this is the linear programming formulation defining the product mix optimization problem for manufacturing two types of computers, X1 and X2, with the goal of maximizing profit, Z. The objective function is expressed as Z equals 8,000 times X, right here, 8,000 times X, plus 12,000 times X. That is your objective function, where every unit contributes to the profit. However, production is subject to resource constraints, including labor availability. Okay, that's 300X plus 500X, right, for each of the units, has to be less than or equal to 200,000 hours. And material costs, 10,000 for CC7 plus 15,000 times CC8, has to be less than or equal to $8 million. Additionally, there are minimum production constraints because it requires at least 100 units of CC7 or 200 units of CC8. Okay, so this model helps manufacturers determine the optimal number of every product to produce while ensuring efficient resource utilization and maximizing profitability. So businesses across manufacturing, logistics, and supply chain management use LP formulations like this to optimize operations, reduce cost, and improve decision making. So Excel's Solver add-in allows you to use linear programming by optimizing an objective function while considering constraints. So by setting the objective cell, which is profit, by setting the objective cell, by setting the profit, right, the objective cell, and defining the decision variables and applying constraints, Solver can help you find the most efficient solutions for resource allocation, cost minimization, production optimization. So using Solver, we can solve this linear programming problem by defining the things that we said: decision variables, optimizing the objective function. So the model incorporates constraints, the labor limits, the budget constraints, and make sure that we have realistic resource allocation. Solver is then going to compute the optimal the optimal values for X1 and X2. Okay, determining the best production mix for maximizing profitability while adhering to operational constraints. And this method, like I said, is widely used. Okay. What-if analysis and goal seeking. These are essential tools in decision making, allowing businesses to test different scenarios and determine the inputs needed to achieve a specific outcome. What-if analysis explores the impact of changing key variables or assumptions. For example, if a manufacturing company increases machine capacity by 40%, how would that affect total production? This helps organizations plan for uncertainties and optimize strategies. Goal seeking, on the other hand, works backwards by starting with a desired result and calculating the necessary inputs to achieve it. So a common example is break-even analysis, where businesses determine how many units they need to sell to cover cost. Now, both techniques are widely used in financial modeling, in supply chain optimization, and sales forecasting, helping companies make more informed, data-driven decisions. So here's a what-if analysis example, demonstrating how changes in initial sales and sales growth, how that impacts annual net profit by modifying the cells B10. By modifying the cells B10, these are the initial sales, and cell B11, which is a growth rate per quarter. Businesses can then evaluate different revenue scenarios and their effect on profitability. So for instance, if we start with 100 units at 3%, then that results in a net profit of 127. Okay. This is what this looks like here. Okay. While 120 units at 4% would equal something else. I don't know. Okay. So that's what this is all about, right? This approach allows you to model different pricing, sales, and expansion strategies to optimize financial outcomes. So what if analysis, it's widely used in financial forecasting and budgeting. It's widely used in strategic planning, helping decision makers test multiple assumptions before committing to a business strategy. So there's also GoalSeek in Microsoft Excel, which helps determine the necessary input value to achieve a desired output, such as finding the break-even point where profit equals 0. So in this example, the business is currently at a $6,000 loss, and GoalSeek can be used to calculate how many units need to be sold at the given price to cover cost and reach profitability. So GoalSeek in Excel is powerful when it comes to break-even analysis. Okay, so here we're initially at a $6,000 loss with a selling price of $3.41. But using GoalSeek, it calculates that increasing the selling price to $4.01 per unit would result in a break-even profit of $0. This analysis can be applied to units sold or variable cost or fixed cost, helping businesses optimize pricing strategies and cost structures to reach financial stability. So we have data tables in Excel, which allows businesses to analyze how changes in multiple variables impact financial outcomes, making them ideal for break-even analysis and sensitivity testing. So in this example, a two-variable data table is used to explore different combinations of selling prices per unit and units sold, helping determine at what point the company moves from a $6,000 loss to profitability. By inputting different values, the business can evaluate various pricing and sales strategies to optimize revenue, to make data tables an essential tool for financial forecasting, budgeting, and strategic planning. We also have sensitivity analysis that uses data tables. And it's going to help you evaluate how changes in multiple factors, like changes to the selling price per unit, changes to the number of units sold, how all of that impacts profitability. So the left table over here, it's showing different profit values based on these variables, and this will help you identify trends and risk exposure. And this right table over here, it highlights the break-even point where the company no longer incurs a loss. And we already know that that's at $4.01. Okay, so this analysis is going to let decision makers explore various pricing and sales strategies, ensuring they optimize revenue and minimize financial risk before making critical business decisions. So decision tables provide a structured way to analyze alternative choices by mapping out possible outcomes based on different conditions, helping businesses make informed decisions. So in this investment example, the goal is to maximize yield after 1 year, but the outcome depends on economic conditions, which can experience solid growth, stagnation, or inflation. So by using a decision table, investors can evaluate how different investment strategies, such as stocks, bonds, or real estate, perform under each economic scenario. So this approach is widely used in finance, risk management, and strategic planning, letting you make, and assess potential risk and rewards before committing to resources. So decision tables helps with that as well. Okay, they're going to help you or an investor evaluate different investment alternatives under various economic conditions by analyzing potential yields, the result variables, based on uncontrollable factors like market growth, stagnation, or inflation. So in this example, investment options includes bonds, stocks, and CDs, with each yielding different returns depending upon the state of the economy. If the economy experiences solid growth, stocks perform best at 15%, while in the stagnant economy, bonds yield a safer 6%. During inflation, stocks suffer with a minus 2% return, where CDs remain stable at 6.5%. This structured approach, it lets investors make data-driven decisions by weighing risk versus rewards, optimizing your portfolio based on expected economic trends. So simulations, this is a powerful what-if analysis technique that creates a virtual model of a real-world system to analyze its behavior under different scenarios, and is commonly used in decision support systems when problems are just too complex for traditional optimization methods, or when systems involve dynamic interactions and uncertainties. Businesses use simulations to test different strategies, reduce risk, and improve decision-making without affecting real operations. For example, airports use simulations to optimize flight schedules. Retailers simulate customer traffic for store layout improvements, and hospitals model patient flow to enhance resource allocation. Simulation helps organizations make data-driven decisions by evaluating different possibilities before implementation. Simulation methodology follows a structured approach to solving complex real-world problems by modeling, testing, and evaluating different scenarios before implementation. The process begins by simply defining the problem, and then constructing a simulation model that represents the real system. The next model is, after that, the model is going to be tested and validated, of course. Okay, after it's been tested and validated, we're going to have some experimental design and execution, so we can explore different conditions and outcomes. So the results are then going to be evaluated, of course, so we can identify the best possible solution. And once a decision is made, that final decision is made, then that final solution is going to be implemented into the, quote, real world. Okay? And this is iterative. Okay, so this is used across all industries: manufacturing, healthcare, finance, logistics. It's used very often. Different types of simulations help businesses analyze complex systems and decision-making processes under various conditions. Probabilistic simulations, such as Monte Carlo simulations, use probability distributions to model uncertain variables, like demand forecasting or financial risk analysis. Companies like Procter & Gamble use it to hedge foreign exchange risk, while utility companies predict water demand. So time-dependent or time-independent simulations help determine if timing impacts outcomes, such as in supply chain, logistics, or peak hour service demands. Discrete event simulation models interact between entities, such as estimating wait times in retail checkout lines based on the customer's arrival rate. Lastly, we have visual interactive simulations, which lets decision makers see how a model functions in real time, making it useful for process optimization, for interactive scenario planning. So these simulations provide businesses with valuable insights for risk mitigation, for efficiency improvement, and strategic planning. So visual interactive simulation, it enhances traditional simulation methods by incorporating computer graphics, animations, and immersive environments so that we can analyze and optimize complex systems. This type of system integrates RFID, GIS, virtual reality, VIS. These virtual interactive simulations, they allow decision makers to interact with the models dynamically, making it ideal for urban planning, traffic management, and facility layout design. For example, city planners can simulate different road layouts to visualize traffic flow improvements. Retailers can optimize store layouts by analyzing customer movement patterns. So the ability to see and manipulate models in real time makes visual interactive simulations a powerful tool for strategic decision making, risk analysis, and process optimization. In 2025, several simulation software solutions have emerged as industry leaders. There's ANSYS, and this is good for engineering simulation capabilities. ANSYS enables virtual product testing across industries like aerospace, automotive, and industry. There's Simulink. Simulink was developed by MathWorks. It provides a graphical environment for modeling and simulating dynamic systems. It's widely used in control system design and digital signal processing. There's AnyLogic. AnyLogic is a versatile simulation tool that supports multiple modeling methods, including discrete, event, agent-based, and system dynamics, making it suitable for complex business processes and supply chain optimization. There's Arena Simulation. It says software, but we all know it's spelled S-O-F-T, software. Arena Simulation software. It's known for its intuitive interface. It's really made for discrete event simulation. It lets you model and analyze processes in manufacturing, logistics, and service industries. There's Simulate, which gives you a web and a desktop version so you can rapidly build and share your simulation models. So anyway, integrating features like machine learning and process mining to all of these just 10x's their capabilities. So these platforms enable organizations to visualize complex scenarios, experiment with variables, make data-driven decisions to optimize performance and efficiency. So, simulation and optimization techniques. These are essential tools for modern decision making. This is what enables businesses to analyze complex systems, to test various scenarios, to make data-driven choices, from linear programming to resource allocation to what-if scenarios and goal-seeking in Excel. So these methods help organizations minimize costs, maximize profit, optimize processes. You have all of these advanced simulation tools that provides dynamic modeling capabilities across industries. So by leveraging these technologies, businesses can reduce risk, improve efficiency, and stay competitive. So the ability to simulate real-world conditions, to predict outcomes, to make informed adjustments, this just ensures that organizations can adapt to uncertainty and drive sustainable success.